Hello everyone, welcome to this video of OpenFoam. So in this video, I actually want to continue where I left off. So last video we were messing around with some of the time functions where we actually declared runtime as an object. Okay, or OpenFoam declares, or the create. Let me be more precise. Okay. The create time.h script actually defines runtime as an object, and what all of these are is that it obtains, or it gets what do you call it? It gets all these functions within this runtime object, and it starts to run them. So we played around with that in our sandbox code. Okay, so for now, next thing we want to try and understand, okay, since we already understand, what create time is, what is this, okay, all of this we have add post process, add check case options.h. Well, probably they are important as well as a piezo control. But what is most of interest to us is how equations are being defined and solved. And of course, the quick answer would be, if you take a look at the temperature tutorials, adding temperature tutorials, you'll be able to see how the new equations are defined. So for example, the most simple in your tutorials are to use this thing called fvScalarMatrix. Okay, fvScalarMatrix. All right, so this is it's a class, of course, and it's actually taking a lot of namespaces, the FVM namespace, probably the finite volume matrix namespace, and inside this class you will have the solve function. So you can look for scalar matrices, and the other thing you would probably want to look for in your create Fields.H is actually this thing called volScalarField. Okay, so again, just saying these two things are kind of different. One is that you need to know what a volScalarField is, and one is where this FV scalar matrix is. Okay, you sort of want to acquaint yourself with these classes. Okay, so did some detective work. All right, and the main things I like to use are the grab function and the find function. So I will use these again and again. Now, let me go through some basics first to maybe start acquainting you with where these functions are defined. If you're not interested, if this is not of interest to you, you can of course skip this video. Then you can look at other things, but yeah, I rather do it slowly and sequentially so that you can acquaint yourself with some of OpenFoam's functions. So after some detective work, I found that this volScalarField class, okay, so you just navigate to your source directory by typing src. Like if you type app, you go straight to application. If you type src, you go to source. If you type alias src, you see this. It's a change directory, right? So the place where these volume fields, volScalar fields are defined. So you go to this place called finiteVolume. Okay, of course you can do a grep here, grep. Okay, I won't do that. Okay, I won't put you through that. I'll just go straight to where these things are found. Go to finiteVolume. Go to fields. Go to volume fields. Okay, this is where you will find all the code pertaining to volScalar fields. So if you go to volFields.H, okay, this is what you have. You will have lots of, again, a header guard over here. Then you have an if. All right. So if it's volFields.H, volume fields is not defined. You'll define all of this. You run all of this code. There's GeometricFields.H, volumeMesh.H, etc, etc. Okay, I will not go through all of this. Okay, you will see this thing called the template, and if you are not sure what the template is, here is one article that quickly goes through that, but I'm not going to go through the thing in detail. Okay, I'll just say roughly, yeah, a template is basically a template as the way you understand templates. Okay, so I'm not going to go through that, but what I will say is that you have this, you won't see this volumetric what do you call it, volumetric scalar field being defined here. So this class is not defined here. So what are your closest bets? Okay, you can take a look at volFieldsFwd.H and volFields.I.H. So I'm going to clear this and I'm going to cat volFields.I.H because that's one of the places you can look. Okay, again, well, what do we have here? It's just another template, okay, with not a very descriptive, nothing descriptive of volume scalar field. You don't see anything there. Okay, and okay, in case you are confused by the constant, C++ constant, it basically means defining a variable that you can never change. So if you, for example, if you define a variable called I equals 5 and I is an integer, and you say it's a constant, well, if you try to change the value of I, then the compiler will give you an error. Okay, that's what constant is, very quickly. Okay, but I will not elaborate on this. That's not the point of this video. These are just some handles for you. Okay, the other file we can look at is volFieldsFwd.H. Okay, so in volFieldsFwd.H, you will see again a header guard and all of these things here. You'll see this thing called class volume mesh, class fv patch field, and then you'll see this thing called typeDef, and you see this thing called volume scalar field and volume vector field. Okay, so this is where your class is defined, so to speak. All right. So you can see that a volume scalar field is basically the same as a geometric field of the type scalar, and it has fv patch field and some volume mesh. Again, I don't really know how. At this point, I don't know how this geometric field actually runs, but it's probably a function type or class type. Okay, so anyway, I'm probably getting all my terms wrong down here. There are probably better names, class inheritance. I'm not too sure of the pinpoint details at this moment, but you can see where volume scalar field and volume vector field actually come from. So you can see over here, when you do your create fields.h, you will start needing to, you will need to create fields. Let's say for your velocity and your pressure and your temperature, you just need to start making fields from them. So for example, temperature, you will expect it to be a scalar. Pressure, you'll expect it to be a scalar, so they'll be of the volume scalar field class. And you define, then P is actually an object, well, that represents pressure. It is an object of the type volume scalar field, and it has these properties. When you initialize it, when you initialize the thing. Okay, so there's an input output object, blah blah blah, same for T. And then of course you have your volume vector field here, which is of the type geometric field. Okay, so if you're not sure what a typeDef is, you can go to Wikipedia here. So typeDef, basically, the long story short, it's I'm not going to go through in detail, but basically the typeDef is a special kind of variable. For example, if integer can be any kind of number, right? But length is a subset of integer. Okay, length is a subset of integer. Integer can be any number, but length is a subset of integer. So all lengths are integers, well, in this typeDef, but not all integers are length, because integers can mean other things as well. For example, a speed here like kilometers an hour, or points. Well, all of these are considered in this line of code to be the type integer, but these are so-called more specialized. Okay, so if you don't want to keep typing integer, integer A, integer B, blah, blah, blah. You can make so-called subsets of these types, all right? So likewise, when you have a geometric field, the geometric field is a little bit more generic, but volume scalar field and volume vector field are more specialized versions of the same thing. You also have volume sim tensor field, volume tensor field, volume spherical tensor field, etc., etc. Okay, so in case you're wondering what volume geometric field is, where to find it, okay, I did a detective work for you. You can go to source OpenFoam. Okay, go to source OpenFoam. This is where you find most things, and you can go to fields, and you can go to fields again. And over here, you will find, you should be able to, oh, wrong one. You should be able to find your geometric fields right here. So go to geometric fields. Let me pwd, print which directory. It will be under source OpenFoam fields geometric fields. And even over here, you'll find lots of files. So the one you'll probably want to go to is geometric fields. Okay. That's the thing about object-oriented programming. If you have very, very big programs, well, this seems to be the only way to compile everything in big programs. So at least all the codes are kind of segregated nicely. So where do you find it? It's in GeometricField.H. Okay, you will see a lot of bits of code and functions over here. For example, for example, all of these are constructors, meaning to say, if you want to define a geometric field, well, volume scalar field is of the type geometric field. If you want to do that, how can you do it? Okay, you need over here you need an IO object, you need some sort of mesh, and so on and so forth. Okay, so this kind of gives you the template of what kind of input this geometric field file needs. So all geometric field files will need all these kind of inputs, and volume scalar field is a type of is one kind of geometric field, and it will use the same input pattern as a geometric field, just like you see here, IO object and mesh. Now again, I won't go too much into detail into what these are, but all I'll say is that, okay, you just follow this template, more or less you'll be okay with adding new volume scalar fields. Okay, so what did we go through? We went through some detective work on where these volume scalar fields come from. Then what are the types? Okay, and if you want to know what these kind of types are, you can see that this is a dimensioned field. Okay, dimensioned field. All right. So yeah. So you see, this is a class that the class is a geometric field. It will inherit properties from this class called dimension field. So this is some concept of inheritance. So I'm going through very, very much a roller coaster of stuff here. Again, inheritance, C++. So I'll put all of this in the description. Don't worry what it is at this point in time. If you know, you know. If you don't know, don't worry about it just yet. But this is the syntax on how inheritance is supposed to be. If I need to go through in detail, I'll go through in detail, but not now. Okay, let's just see how deep this rabbit hole goes. Okay, so we go through geometric field, and we find that, okay, geometric field inherits certain classes and functions from, or certain functions from the class dimension field. So where do you find dimension field? Okay, you can go up, and then you will see dimension fields over here. So go to dimension field, and you cat DimensionedField.H. All right, you will see where dimension field is, okay, defined. The class is dimension field, and you have all of these properties here. And you can see the input syntax is very similar to volume scalar field and geometric fields. So so this is actually, this is actually what? Okay, the class is a dimension field, and it will inherit what do you call that? It will inherit so you can see if you have this class and this is the child class will inherit from the parent class. Okay. All right. So I'm going through this very quickly. But basically, long story short, the dimension field class actually will inherit. It will get the functions from the reg.io object and the field. Okay. So this is where the rabbit hole goes. And the field, if you go into Field.H, you will be able to find where this field is defined. Okay, this is where the fields are. Okay, cd fields. Okay, there's no .h there. Go to field and you should be able to find Field.H right here. Okay, so again, you have a long line of classes, and again, this field actually inherits from the field base and list. Okay, so I'm throwing a lot of terms that may be confusing, but yeah, if you are familiar with C++, hopefully it doesn't scare you. It should be okay. If not, let me just try to just illustrate what's going on here. All right. So you have your volume scalar field, which is of the type. Is one kind of geometric field, right? So this is the class structure. Okay, the geometric field is actually a huge is a class. Yes, it's a class. Okay, and it has a huge assortment of functions. Okay, where do these functions come from? Well, OpenFoam has structured it in such a way that, if you have dimension field, so I'll just call it dim field. Okay, so this is yet another class which you saw just now, and it will have its own set of functions. It will have its own set of functions. So what happens? Okay, I used the term inheritance pretty loosely just now, so let me explain it. Okay, this when geometric field actually inherits the functions from dimension field, it says that all the functions in dimension field will become functions of the geometric field. Okay, so geometric field will inherit all the functions from dimension field into geometric field. Okay, and then of course you can add your probably down there, maybe they will add some other functions also. I didn't read the code that properly, but this is where I want to illustrate. Inheritance is very often used in OpenFoam. So again, dimension field in turns, where does it get its functions from? It will get its functions from Field.H, or the field class, and some other classes as well. I can't remember which one. Maybe it's IO, input output, and so on and so forth. So in this way, geometric field will, you don't have to put so many functions in geometric field. Okay, maybe there are hundreds of functions. Maybe you only need to add maybe in this way you can package your functions pretty nicely. So this one you can have maybe 5 extra functions which are specific to geometric field. Maybe dimension field has 80 functions already, so I don't have to rewrite all my 80 functions in geometric field. Well, it's not mine, it's the authors of OpenFoam. So that's how they designed the code to make it sort of neat. But anyway, this is how the structure of all these fields will be. Okay, so right now geometric field and volume scalar field, there's so many layers up that you can't see one big file where all the functions are being used. So it's a little bit difficult to see. But this is how OpenFoam likes to structure their files. Okay, yeah. How then do you know how to use all the functions within let's say these files? I mean, I have not even touched on the volFscalarMatrix thingy in in IcoHeapFoam. If I cat t equation.h, I still have another class I need to explore, which is fvScalarMatrix. I have not even touched on that. Okay, but before I go, I'd like to bring you to this. Yeah, you might be wondering how then can I take functions from each of these classes and know what each of them does, okay, and learn how to use them. Okay, so the equivalent of the tutorials directory, the equivalent of the tutorials directory for source code. So let's go to app. The equivalent of your tutorials directory, if you want to know how each of these functions are used inside OpenFoam. If you want to know how these functions are used, you can go to this place called tools, or rather, sorry, you can go to this place called test. Okay, test will have an assortment of makefiles, an assortment of C files for you to test your functions. Okay, so we were talking about volume fields just now, right? Okay, you see that over here we have volume field right here. So let's go to volume field, and this is the closest we can sort of the closest relative of volume scalar field we can get. Okay, volume scalar field. Okay, so we can see that volume scalar field is being used here. All right, and of course you can do a grep arm volume scalar field. Here also, you'll see there's so many places where volume scalar field is being defined as a class and also being used. Okay, but I digress. The point is that if you want to see how some of these OpenFoam functions and classes are being used so that you can make your own code, you go to the test directory, and then you see some of these example files, which are called test files. Okay, for example, you see this volume field, volFields.C, test volFields.C. It already has all the C++ syntax for you, and an example already done. Okay, so it will give you code that is specific to the set of functions or the classes that you want to use. For example, the geometric field, or GeoField in this case. Okay, so you can see that the volume scalar field thing is being used here, volVectorField is being used here. Okay, and then you can see that the geometric field objects are being declared or being used here as well. Okay, so yeah, this is you can see them being loaded up with an IO object and etc. etc. You can see some other classes here as well. So what's going on here is that geometric scalar field is pretty high up in this hierarchy, right? Okay, it's pretty high up in this hierarchy of so-called lots of functions and classes. Okay, so there may be lots of custom functions which are unfamiliar at this point in time. But the long story short is that, okay, if you want to learn how to use this geometric field class, you don't have to start from scratch. You can actually look in this directory to see how this class is being used and defined. Okay, so in fact, previously we were looking at polynomials. Specifically polynomial equations. So if you see here there is actually a C code for linear equations, which we were testing in the last few videos. Okay, so these are some, or this is an example file of how to use this linear equation sort of what do you call it? Yeah, linear equation code class, linear equation class. So you can see here are some test constructors or whatever. Basically, it's how to initialize your linear equation class. Okay, so this is where you can find your linear equations. You can even find your quadratic equations, as you would have seen just now, polynomial equations. Okay, the cubic equations, quadratic equations, you will see example codes there as well. You see things in the polynomial class. Okay, so polynomial class you will also see here. Okay, an example C++ code of all these classes being used in action. Okay, some of them may not be so straightforward, but at least there's something there to start off with. And of course, if you're even more interested, there is one part where you can use OpenFoam libraries to solve ODEs. That's pretty useful if you want to talk about making your own custom solver and somehow you need to solve ODEs, because these happen a lot. Okay, so you can vim test ODE.c, and then you can see, all right, you can see these ODEs are defined very similar to MATLAB code. Okay, so you have dy dx, which is a vector, or rather an array of sorts, and it's supposed to contain these things over here actually contain the system of equations. They're under the void function derivative. Then of course you can define Jacobians here. I'm not going to go into detail. And here is where you actually start to discretize, I guess, your ODE, create your ODE system. Okay. And of course, you can actually specify a solver, and then it will solve this system of ODEs for you. So, yeah, some useful resources for you are all these links here: what the typeDef is, what a template is, what a constant is, what inheritance is. And this one is very useful, how to solve a simple ODE using these OpenFoam libraries in C++ code. And this is another document actually detailing how to solve them. Okay, so what did we cover in this video? We covered a lot of ground. Okay, so we covered some of the hierarchy, how these classes are so-called defined, how these classes in OpenFoam libraries actually inherit from other classes. So there are many layers. So for example, volScalarField, even that's a lot of classes it's inheriting their functions from. I also showed you the directory which you can go and check and at least take a look, so that you don't have to what do you call it? Yeah, you don't have to think from scratch. How am I going to use all these functions in there? If I want to custom design my own solver, you can actually just look inside the test directory, and that's at least the code may not be so simple, but at least it's a starting point for you. Okay, so we went through the GeometricField, the DimensionedField, the Field.H, the ScalarList.H. And didn't we go through ScalarList? I don't know. I can't remember. But those are things that the field actually inherits from. Okay, the includes, and you can see all the inheritance structures. Okay, so we also saw this in this test directory. Not only can you take a look at how to use some of these functions in volume field, you also see your polynomials popping up here. How to use this polynomial stuff in C++, and how you can even solve ODEs here. Okay, that's just a lot. There's a lot of things you can make use of. Just got to know what you're looking for. Okay, so hopefully this has acquainted you with yet another important class inside our OpenFoam. So yeah, just let you know where the class structures are and where you can see an example of some of these classes being used in C++ code. Alright, so no programming this round, is just to induct you and get you familiarized. That's all I have. Thank you for watching. See you again.